for all the audience, thank you so much for heading over to the HP Dev Talks. And today I'm looking forward to help you all get started with Python. So Python basically is an interpreted, high level and a general purpose programming language. It was conceived in 1980 by Guido van Rossum. And installation of Python is pretty simple. You can just head over to the URL that is mentioned over here, python.org, and it has got its binaries for all the platforms like Linux, Mac OS, and Windows, and you can download the one that is suitable for you and install it. But before getting started with what exactly we can do with Python and what are its basic features and syntaxes, I wanted to tell you that there is something in the programming paradigm, that is, programs are mostly written to be read by human beings and rarely for the computers, which is why readability of a programming language is very important. And when it comes to Python, Python is an extremely well readable language. Writing code in Python or reading a Python code appears as if you're just talking to another person regarding some instructions followed while solving a problem. So that makes the best part of Python, why it is loved by most of the programmers all over the world. Another thing is that Python's community support is extremely good. So you'll find answers for anything you are stuck at. And there are a lot of open source libraries that are built on top of this Python that can be leveraged for most of our projects that will really ease our life. So with this brief introduction about Python, let's do our first shake hand with Python, writing a hello world code. If you have headed to your notebooks over there, you might find the introduction to Python Jupyter Notebook. Hope you have all clicked and logged in. So you can just come over to the section 1 of it. Let's write our first Python code. So as I mentioned, Python is meant to be an easily readable language, and its formatting is very visually uncluttered, and we feel like talking while writing a Python code. So if you want to print any statement in Python, you can just use the function print, which says the keyword print, parenthesis, and write your string inside it. If you run this, which already has print of hello world, hello world gets printed. So I'll just pause for a moment and wait for you to try, and I just want to.
For those not familiar with the notebook, I just add that there's a run button at the top, so a cell can be run by pressing the little play button at the top. Yeah, right. Thanks.
So I hope you people got how to print the statements like hello world. And let's proceed with taking a console input. That is, I want us to input some name or some string and then concatenate or attach that string with hello and greet oneself, right? So let's execute this line where I'm telling name equals input of please enter your name. So input, just like the function print, input is the function which will let us consume the console input in Python. So you can see I'm taking the function input and giving or prompting a statement called please enter your name inside it. And whatever value the user types in, that is stored in a variable called name, and then that out. So I'll just run this cell, and you can see I'm prompted with a input field where I'm supposed to enter my name. So I'll just enter my name. I'll say Samarth and press enter. So you can see in the next line, it prints me hello world. So this is one way to print a statement and to consume a console input and then concatenate or attach it with a print statement. So inside the print statement, we can just put a comma and then write the name, right? The variable of the whatever the name got stored. So are you guys able to do this? Didier, can you just tell me if people are
Yeah,
responding or not? I
we are
cannot
trying to answer
see.
the question, so you can go on. I think most people are able to get this right. I think somebody
Okay,
was
great,
mentioning Control Enter is also a shortcut, a keyboard shortcut to execute the cell. Thank you, whoever answered that. So we got lots
that's
of
fine.
yes, so I think we're good. You can go on.
Great. So now that we are done with the print statements and the way to consume the console input, let's try to understand different types of variables and data types in Python. So in a program, variables are the logical names that we give for the memory addresses that hold the data that you need for your computation. For example, let's say we want to add two numbers, that is 10 and 20, 10 plus 20. So this 10 and 20 needs to be stored in the memory and they will be fetched and then computed to find the sum. So these two, when they are stored in the memory, in order to refer to those memory addresses, we actually make use of something called as variables. And variables can be of different types. That is, they can store data of different data types. They can be numeric, they can be string, that is a character or a sequence of characters. They can be Boolean, wherein true or false kind of a value. It can be custom data types in the form of objects of classes, and it can also be lists, that is collection of values. And there are many more types in Python, but these are kind of very basic, and these are a kind of a traditional data types which are widely used. So the best part of about variables in Python is that unlike C, C++, and Java, we need not declare the variables and their data types first and tell the compiler or the interpreter that what kind of a variable it is. Instead, we can just start dynamically using them, and Python will understand by itself like what is what, whether the data type that is stored in a particular variable is an integer or a string or a character boolean or a list, whatever it is, right? So in this cell, I have just created a few different types of variables and stored those data in those variables. So you can see that an integer equals 10. So on my right hand side, 10 is an integer, and on my left hand side of the eq, right, an integer, it's the variable name that I have given. So similarly, a float that is on the left hand side, and that is the variable name, and 12.5 is a float data that I have assigned to that particular variable, a float. Likewise, string or the character S is stored in a character, and string Teddy Winters is stored in a string variable, and the Boolean value true is stored in a bool, right? So we can just execute that, and all these data get stored into their respective variables over there. And we can make use of the previously learned print function to print out these examples and see if that value which we just stored. So you can see that integer example printed me 10 because that's what an integer variable is holding. Floating point example printed me out 12.5 because a float variable is holding 12.5 from over here. Character example is holding character S, because that's what we assigned over here. And string example is holding me Teddy Winters because of the assignment above. And then finally, Boolean is holding me true because I've assigned it true. Let's say I'll just go and assign false to a bool now, right? I'll just execute it, all these again. And you can see that now my Boolean example is showing me false because I modified the content which that variable was holding, correct? So if we want to check the data type of the variable which Python is holding over there, then there is a function called type, which will help us for identification of the data type variable is holding. So I'll just pass in the variable name to this function type, and it will the type of variable it is storing. So type of a bool is Boolean data type. It just printed me bool. So I'll just show you another example by printing out float, the type as float, right? So I can also pass in a string variable to the function type, and it should show me that the data type string variable is holding is a string. So till now we learned about print statements, put function to accept the put, and how to create a different kind of a variables and how to access them inside my print statement, and also how to identify the Python. Hope things are. So now let's understand the console input variable assignment, and let's try to do some sort of a math. So this example we have already seen where we just ask the user to take in another, the name and greet them. So I'll just say Teddy and it says hello Teddy. Now let's look at another example and try to store those values in variables and do some mathematics on top of it, right? So I'm having a variable called dividend and I'm the input, enter the dividend. So you can see that I'm doing some sort of a operation over here. This is called as typecasting. When I accept an input from the user using input function, whatever value comes, whatever the user types in, is always, in order to convert that string into integer data type, I do this typecasting. Okay. So I'm first consuming the input and assigning it to the variable called dividend, and then another input, and I'm assigning that to something called as then I'm going to do a division operation using those dividend divided by divisor, and whatever the value comes, I'm storing that value in quotient. Okay, and then I'm going to print the statement that the quotient is whatever the result will be stored in this variable quotient, and I'm going to print the type of it. Okay, let's execute the cell. So it asks me to enter the dividend. Enter 100. And then it asked me to enter a non-zero divisor. So I give 2. So now the quotient has to be type 50, quotient has 50, and the type has to be float. So you can see over here, the last statement, this print statement just got printed telling the quotient is 50.0 and quotient is of type so and so class, that is float. So why this 50.0 came is I'm typecasting the divisor as float, and anything that gets divided by float will be float. For example, like integer divided by a float will be a floating point value for me. Okay, so that's how we are going to concatenate these values. So you can see I am introducing the values quotient and this type within this string. The quotient is braces and quotient is of type braces, and I'm using the function called format. So if you have different variables which you just want to place them within the print statement, then this is a way to do it. So wherever there is a placement of the variable, you put braces, open braces, close braces, and then you apply a dot format function after the string is completed, after this double quotes. Okay, and then within that function called format, you pass in all the variables in the right sequence you want it to be filled. So this is how we can take console input, we can assign it to different variables and perform some sort of a math. Now let's jump into some more complexities of testing some conditionals and deciding the logic to operate upon. We call them the if-else statement or the else. So these are very common for our day-to-day life. So if some condition is satisfied, then go do this logic, otherwise execute some other logic, right? So let's consider the previous example but enhance it further to see if our divisor is for sure a non-zero number. So I will be taking the dividend, a console input. I will also console input the divisor, and here we will just write the keyword if, and we write the condition using our variables. I'm telling if is a keyword from Python that checks a condition. So this is the condition over here. The variable divisor is not equal to 0. Then proceed with the operation of division, that is quotient equals dividend divided by divisor, print, and then else print stop cannot divide by 0. Okay, so something that is important over here is the indentation of these two lines that form the if. You see there is a 4 spaces is left that tells that it belongs to the if statement. So whatever block concept we have in other programming language, that block scope is introduced in Python using 4 spaces or a tab. four spaces is mostly recommended. So whatever is indented with four spaces is under this if block, and the moment you come out indentation, you will be out of the scope of that if block where I have written my else. So whatever I want to be under the else block, I want it to be indented with four spaces and again written. So if is a keyword, I'll just repeat again. If is a keyword and we have the condition over here, that is, I take the variable divisor and see if it is not zero. So exclamation equals is the not operation. It's operation in Python. Okay, so double equals would be comparison for equality, and exclamation equals would be comparison for inequality. So if divisor not equal to 0, if I give any value other than 0, this condition will be true and the control will enter this block, it will do the division and proceed with the print statement. So let's enter the dividend. I'll again type 100, enter the non-zero divisor. I will give 2 again. So you can see the quotient is 50.0. Now let's try to rerun this and give a 0 divisor. So dividend is 100. I will give a 0 as my divisor, and you can see it prints me stop, cannot divide by 0, right? So when I gave a non-zero divisor, it entered the if block. When I gave a 0 divisor, it entered the else block. So I hope you are now pretty comfortable with usage of this if else thing in Python. So proceeding with the loops. So there are many scenarios while programming wherein you will have to iterate or go through a code block again and again until some condition is met. So this is called as looping, and there are two different looping constructs in Python. One is for and another is while. So looping with for is pretty straightforward. So let's write the multiplication tables using loops. So I have taken the multiplicand as 3, and I would like to print out statements like 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and so on until 10. So the construct for loops in Python goes like this. For I in range, and you pass two ends of the range. So 1 is going to be the starting point of that range, and 11 will be the ending point of the range, but it is not included. So when I say for I in range 1 to 11, it actually runs through number 1 till 10. So whatever the last number you are telling will not be included. So if I mention it as 20, it will just run through 1 till 19. Okay, so range is a function that gives you all those numbers in between the passed arguments, and the second argument that is passed will be up to that number but one less than that. Okay, so we just wrote for I in range 1 to 11. So this is going to run from 1 to 10, and then I'll just print out this multiplicand, that is 3, that will be coming here. I'll just write an X, and then this I is the iterable. So this I will change as 1, 2, 3, 4, 5, etc. And I'm printing out equals. And here at the end, I'm actually doing the math operation multiplicand times I. So it will be calculating 3 times 1, 3 times 2, 3 times 3 for every iteration. So if we execute this cell, you can see that the multiplication table for 3 gets printed. So when for loop started, I took the value 1 and it performed the operation 3 times 1 and it equated to 3. And then I took the value 2 in the next iteration. It performed this operation and computed the value to be 6. Okay, over here. And then the loop went on till 10, and then when it became 11, the condition fails over there. It's not in this range, so it will just come out of the loop and exit itself, right? A similar thing can be achieved using while keyword. So in this, you don't make use of a range kind of a thing, but instead you provide a condition till condition this particular loop should end. So you can see I'm going to print the multiplication table of 5 now, and I have the keyword while, and I'm telling there is a multiplier which is going to start from 1, and until the multiplier is less than or equal to 10, you go on looping this logic to multiply the numbers and print the statements. And under every iteration, you increment this multiplier by 1, right? So if we just execute this guy, it will just print me the multiplication table. So while loop will consume a condition over here, and for loop will be consuming a range. And one thing which we want to remember over here is that inside a for loop, the increment of this number I happened automatically because this range is going to pass the one by one integers within that range, right? So it will just pass 1, 2, 3 all by itself. But in a while loop, we have to take care of that increment of the conditional variable ourselves. So I have initialized the variable multiplier as 1, and I'm incrementing that multiplier by 1 for every iteration so that it actually takes the value 1, 2, 3, and ultimately it will hit 10. And then when it becomes 11, this condition fails and the control comes out of the while. So I hope the usage of if else conditionals and loops as for loop and while loop is pretty handy and understood by most of you guys.
So before Samarth moves on to explain tuples and lists, let me just add a little section in this notebook and cover it for collections. In Python, there are several ways you can do collection, or sometimes we hear people talk about arrays. You can use set, dictionaries, list, and tuple. I will cover set and dictionaries, and Samarth will go on and continue with lists and tuples. They are collections, but they have specific properties. For example, a set is known to be unordered and unindexed. You cannot have duplicate members in a single set. Unordered mean that you cannot make any assumption about the order in which items are stored in a set, nor can you request a particular item in a set by using an index. We'll talk about that. Dictionary is still unordered in that sense that still you cannot make assumption about the order in which items are stored, but the content is changeable and can be indexed. So you can retrieve an item using an index in a dictionary. You can still not have any duplicate members. Later on, Samarth will cover lists and tuple, and both of them are ordered collections, and this is the important piece, both of them can handle duplicate members, and the list is changeable, and the tuple you will see is unmutable. So let's focus first on the sets. So that's kind of the simplest one. A set is, as I said, unsorted. It cannot be indexed, but what you can do typically is iterate through members of the set. You can add new items and remove value from a set. You can, of course, look up if a value belongs to a set. We use curly brackets to manipulate sets. So you see here in the example here. So you can see here a set where we have 3 colors. So it's called set 1, and you see curly brackets, and each item in the set is written with as strings, and we have like a red, green, and blue. And then we can iterate in a set using a for loop and print. We can also print the content, the number of items in a set using the function len. Then we try to add, first we check if a color is in the set. So let's say we have initially red, green, and blue. Black is not part of the set. So if we print the question, if we print is black in set 1, it should respond false. Then we use the add function to add black into the set and ask the same question again. Is black a color? The evaluation of black in set 1 should return true. And then we print the length, which should be one more, so 4, and we print the content. So let's run this piece of code for sets. So you see length at the beginning is 3. We see our 3 item. We can see that black first is not part of the set, so the statement in set is false, while it is true after we added the color in the set. We see that we have 4 items, red, black, green, and blue. You see, by the way, when we talked about this unordered list, we can see that black was put second in this list, but we have no control over this. We can also merge sets together, like we will do in the second example here, or clear content for a set. So you can try here that what you see here is for all the, we look at set 3, we will see that it's empty, len will be 0. Then we do a union of set 1 and set 2, which we store in set 3. And we print the items and the length of set 3. Then we clean it up using the clear function, and we print it again. You will see that it's empty again. So let's try that. So we see length is 0. Then we merge 2 and 1, which were 3 items and 2 items. It makes 5 items, and we can see the 5 items here. Then we clear, and we see that it's empty. So that's for set. So let's focus on dictionary. So dictionary are still collections of items which are unsorted, but they are made of key value pairs. They can be indexed, and actually we are using the key as an index to retrieve the values. Keys have to be unique, and again we use curly brackets to manipulate dictionaries. In this example, you see that we're using a dictionary called dict1, and we are defining what's in the dictionary. It's 3 keys. One is brand, the value is HPE. Another key is model, and the value is HP synergy for IT. And the third key is CPU, and the value is an integer this time, not a string, and it's 2. So we can print that dictionary. We'll see that in a second. We can retrieve the dictionary's brands using the square brackets, which this syntax is often used referenced as the array syntax. So we want the brand value, and we print it. We can also use a function called get on a given dictionary to retrieve the value of the given key, alternatively to the square brackets syntax here. So if you do a dict1.get of the model, you will retrieve the model value. And finally, we retrieve in variable z the value for key CPU. Let's now pretend we want to make some changes. We change the model to be a different synergy, and the CPU to be 4 instead of 2. And we print it again using the get syntax. So we do a dict1 get of the brand, the model, and the CPU. So let's see what we get from that. So if we just print dict, you'll see we get a curly bracket representation of the key current value, which pretty much looks like JSON, comma separated. Each item is comma separated. Remember what we did next? We retrieve using the array syntax. We retrieved the brand and we print it. So X was HP. Then we retrieved using the get syntax the model for, and we put it in variable Y, which we printed. And finally, we get the CPU key, and we stored it in Z. And this is what we see here as value 2. Then we decided to modify the dictionary and print it again in one line this time using brand, model, and CPU separated by space. So we see brand, model, and CPU number. Okay, the next thing you can do with dictionary is you can loop through a dictionary to enumerate keys and or values. So for example, here we do a for loop for a variable x in dictionary 1 and we print all the item. Alternatively, we'd like to get the values. So if you loop through the dictionary and retrieve dict1 and using the square bracket array syntax here for item number x, which will enumerate all the values this time. We can also use a specific function called values, which in a dictionary returns all the values of the dictionary. So in this case, we don't iterate over the keys and then we retrieve the value using the index, but we directly iterate over the values. So let's take a look at those three loops. We see the first one, we iterate over the keys. So keys are, remember, brand, model, and CPU. The second loop is we iterate using the array syntax over the values of each keys. So the first one is HP, the second one is Synergy 660, the third one is 4, and finally we iterate again, but this time using the function values on the dictionary, which retrieves the list of values for which you can iterate. And again, we get the same values. All right, so we have also another construct in Python, which is quite nice, using the items keywords, because as we say in many cases, the collection is made of items. So look what you can do here as if you look through two variables this time, you will see that if you do such a thing here, a dict1.item, it will return each key value individually. In the second, what we do next is we look at the key model and we say if yes, no. So if the model is in dictionary, so we can do that, we print yes, model is indeed a key in dictionary 1. Otherwise we print no, it's not. Then we can say the same thing in using value. So basically look up a value instead of look up a key. So if we say is if HPE in dict1 values, then it would say yes, it is if HPE is in the dictionary, which it is the case right now, or no if it's not. So you can run that and see that for the first loop, we have the key value separated by space. So brand is HPE, model is Synergy, CPU is 4. The next is we are doing our two tests. Is model in dictionary? Yes, it is. It's a key in dictionary. So if you do a in dictionary 1, it's looking up for key. But if you do in dict.value, it's looking it up in values. So what you can do next is you can change this. So let's say if I change this to is type a key in the dictionary, and I try again. No, it is not, because there is no type key. We have brand, model, and CPU. Similarly, if you look for a specific value of, I don't know, IBM, no, it's not. Of course, it's not. We don't have any in our dictionary here. We only have HP, HP, Synergy, and 4. We've seen that already in the set, that you can use the len function to retrieve the number of items in a dictionary. And you can also manipulate a dictionary by adding and removing items. And finally, by clearing a dictionary using the clear function, very similar to what we did in the set. So let's rebuild our dictionary to the original values. Then we're going to print the current dictionary content by using the item construct and print each key value on one single line. Then we will look at the length and see what value you get from there. And then we will add another key to this dictionary. Let's say I would like to store as well memory size. So I will add a key mem and a value 256. Then we print it again using the this time again the item construct, and I will print also the length, so it should be one more than what we had before. Then we will use the function pop to remove a key. So let's say I want to remove the CPU key, and we will do that and check again the length and the items that we have in the dictionary. Finally, we will clear dictionary completely and take a last look at this. So let's execute that piece of code. So we see the first time we start fresh from our 3-item dictionary 1. Then we add the key mem, and we see now we have a length of 4, and we have a new key called mem, which value is 256. We remove the CPU, if you remember. So we now have memory, brand, and model, but we don't have CPU anymore, and we are back to a length of 3. And then we use the function clear, and now the collection is empty, and its length is 0. Just a little word of advice when you manipulate set, because when you use the equal operator in Python to assign a dictionary to another dictionary variable, for example, what you are manipulating actually is a pointer, or sometimes we use the word reference, to your dictionary. And you will, if you really want to make a copy of a dictionary, which you might want to say with your assignment, you will need to use the copy function. Otherwise, it's always using a reference. So let's take a look at that. We have a dictionary. We print it once like we did before. Then we create another variable dictionary 2, and we just assign dictionary 1 to dictionary 2. Then we create a dictionary 3, but this time we make a copy of dictionary 1. So what I'd like to do with that is show that in the first case, dictionary 2 is a reference to the content of dictionary 1, while dictionary 3 is a copy of dictionary 1. So let's say we add another item to dictionary 1 like we did before. We add this memory key and set a value of 256. This is to dictionary 1. And now we print dictionary 1, dictionary 2, and dictionary 3. And I will explain what happens here. So we start from our dictionary 1 with brand, model, and CPU. We make dictionary 2 a reference to dictionary 1, and dictionary 3 a copy of dictionary 1. Then remember, we modify dictionary 1. So when we print dictionary 1 again, we see that we have a new key of 256 for memory, a new key of memory with value 256. If you look at dictionary 2, you see that because it's a reference, it's basically kind of a pointer to dictionary 1. So it holds the same value. It has also the changes that we did to dictionary 1. So basically dictionary 2 is mimicking the content of dictionary 1. While if you take a look at dictionary 3, because we use copy, so it's a completely different set, and it stays with the same value, which we assigned initially with just brand, model, and CPU. So be careful when you use the assignment. Maybe what you want is more a copy than an assignment, and in that case, use the copy function. Just to complicate things a little bit, you can build nested dictionaries in Python as well to build more complex data structure. For example, here we create a dictionary 1, a dictionary 2 with another synergy, and then we create a rack variable which is made of actually 2 dictionaries. One is called server 1, and its value is dictionary 1, and the second one is server 2, and its value is dictionary 2. If we print rack and the length of rack, then we print rack and length. So let's take a look at that. So we see that when we print rack, it's made of a key, server 1, and a value which itself is a dictionary made of 3 keys, brand, model, and CPU. And then we have a second item in this dictionary, rack, called server 2, which again is made of another dictionary made of 3 values, 3 keys, brand, model, and CPU. With that, we are going back to Samart's list and tuples.
Proceeding with the next, subheading, I mentioned at the beginning that while talking about different types of data types, that lists is one of the data types in Python, lists and tuples. So lists and tuples are the collection of items which are homogeneous or heterogeneous. So either they can be of same data type or they can be of different data types, but they are collection of those items, data items. But there are some differences between the two. Lists are mutable and tuples are immutable. So lists are mutable means you can actually modify the content of the list items, but tuples, you cannot modify the content of the list items. And list items are enclosed within square brackets and tuple items are enclosed within parentheses. So these two are the quick differences between lists and tuples. So here is an example where I have declared a variable called list items and I'm assigning them different values separated by comma. You can see there is a 10, there is 12.5, comma, there is Teddy Winters, comma, true, all are enclosed within square brackets. So this creates me a list. So if I execute this and print it out, you can see it just printed me the list. And lists, as you know, lists are all indexed, right? So I'll just create another cell over here and show you guys that list items are indexed. And if you want to refer to the first list item, you can just mention it as 0. These are all 0 indexed. So when I say list items, square brackets 0, it is going to print me the first item of this list, that is 10. If I want to print the second item, then I can just pass in the index as 1 and print it. It is going to print me 12.5, which is the second. So proceeding, we can actually iterate through the list items one by one using for loop again. And Python makes it so convenient that we can directly refer to the list items one by one and not via indices. So you can just say for item in list items and then give a colon and then indent it to fall under this for block and then print those items. Okay. So when I execute this, it just prints me all these values one by one. So in every iteration, this variable item will take the list items from this whatever we have created over here, right? And this is just another attribute of the print statement to make sure that all the print statement end with a space. So if you want to separate these list items with a comma, you can just type comma over there for the end equals comma. And if you execute it again, you can see that list items are now separated with a comma. So this is how we can iterate through the list items. Now let's get into understanding what is a tuple and what we can do with it. So we can just create a similar kind of a list, with different data items over there, like string, integer, another list, right? And if you enclose them within a parenthesis, then it becomes a tuple. And as we know, tuples are immutable. So we have created a tuple and we have assigned it to a variable called tuple items. And we can just make use of the print function passing this tuple item variable to print it out. So you can see again our tuple is printed with a parenthesis and whatever items we had passed in while creation of it. And iteration over the tuple items are also exactly the same as we do it for the list. So we can say for item in tuple items colon, come to the next line, give an indentation to make it fall under this block, the for block, and make use of the print function to print the variable item, which is holding each of those values. So this is how we can just print the tuples. Now let's understand the mutability and the immutability of Python lists and tuples. We understood the indexing, right? So right now my list items of 0 is holding 10. But now if I reassign it with a new value 100 and print the list items, you can see that my first element or the first item in the list got changed for 100. So lists are mutable. I can actually change, the contents of the list over there. But if we consider the tuples, you can see that the tuples first item is hpe space dev, and I'm going to modify the tuple item of 0 to hpe underscore dev, and it should throw me a type error telling that tuples in Python are immutable and I cannot change the content of that item. So you can see that I executed the cell and I ended up getting this type error. So here is where we understood the mutability of lists and immutability of tuples. So Python has a lot of scope, like passing of parameters and returning multiple values. All these things internally will be converted to tuples because they should be something, unchangeable, immutable. And internally Python makes use of these tuples, and a string by default is a tuple. So to give you an example, I'll just create a new thing over here. I'll just say name equals Teddy, right? And I'll just print out the character in the 0th index, which is T. If I now try to change the character to be something called as, X, I'll just mention, you can see that again it hit me the type error because string by default is a tuple and tuples are immutable. So once I assign a value for the variable with a string, that is it. I either have to change the complete string or I'll just have to go with whatever I have assigned. So this was all about lists and tuples and how to iterate through the list items and the tuple items in Python. So there is one more wonderful concept in Python called, list comprehensions. And these are pretty powerful. And these are actually the Pythonic way of coding while we are employing lists for our purposes. So list comprehensions are something like a single line of code which will help me generate some sort of a result or a new list as a whole. So let's consider an example. I'm creating a list of numbers from 1 to 10. So I have square brackets with numbers 1 to 10 separated by comma. And now I create one more empty list called squared. And that I do it by calling the method list. This is actually a object and I just create an object of list and assign it to squared so that this squared will have an empty list. So this is more or less equivalent to writing a empty opening and closing square brackets. Instead, we'll just follow the standards and make use of list method over there. And then the regular way of creating a list which has the squared of all these values, that is 1, 4, 9, 16, 25 like this, and store it in this new list is I iterate through every number in this list numbers and I then append the values of whatever is the square of the number. So I say for number in numbers, that is I'm iterating through each of those numbers. I will say take this list squared dot append. Append is the function to add a new element to the list. I will say squared dot append number into number because I need the square. And if I come out and print this variable called squared, you can see that I have the squared of these numbers, that is 1, 4, 9, 16, 25, 36 up to 100. So this was the regular way of doing it. What if I make use of list comprehensions with Python gives me and try to write it in a single line of code? So I'll just create one more variable called squared underscore new equals. I'll just create a empty square brackets over there, and within that I'll write my for loop as for number in numbers. I will iterate through the numbers and I'll just prefix it with whatever I want to do there. I'll just say number times number, and this generates whatever this list is there and directly assigns it to a squared new variable which can be seen by printing it. And this was a lot more easier, right? So let's try out another example with this. So let's say I'll just increment this by 1. I'll just say inc1. What I'll do is I'll iterate through all the numbers. I'll say for number in numbers. I now iterated through all the numbers of the numbers, and I'll store number plus 1 for every number that happens. And I will print this inc1 list. You can see all these numbers just got incremented by value of 1 and got stored in this new list called inc_1, 2, 3, 4, 5 up to 11. So these are list comprehensions. So you can just make use of one-liners to operate on your list items and create a new list. And this is pretty handy and straightforward and looks really beautiful too. And these operations are much more optimized internally by. All right. Now let's jump into another important concept like slicing. Slicing will help you to choose a subsection from the list or tuple. And as we know, strings are also tuples, so slicing can be done on strings as well. So we have got this list numbers, which is having numbers from 1 to 10. And if I just want first 5 numbers, I can just call that variable numbers and provide the index with colon 5. So colon 5 will tell that get all the numbers from this list numbers from 0th index up to 5th index, but not 5th index. Okay, so index 0, 1, 2, 3, and 4. So if I just print it out, so you can see I get the numbers from 1 to 5 because these numbers lie in the index from 0 to 4, that is colon 5. That's how we slice it. And there is a negative indexing also in Python. So if I just say numbers from -5 up to last, so it's like from the 5th element from the last till the last element, print everything for me and assign it in this variable last 5 elements, right? So this is how it prints 6, 7, 8, 9, and 10. And if you want to get a section from in between the lists, right? So somewhere from around index 3 to index 6, then you pass in the values like index 3 colon up to 6. So add 1 to it. So write 7. So index 3, 4, 5, and 6 will just get. So you can see that 4, 5, 6, and 7 just got printed because those are the values stored in index 3, 4, 5, and 6. So this is how we slice to extract the substrings or the sublists. So maybe we will also take an example of a string. I'll just say name equals Teddy, and then I'll just say winters, and I'll just say S. So let's think that first is the first name, second is the last name, and S is just initial. And if I just want the first name and the last name, what I will do is I'll just say name and I pass in colon, and this is 0, this is 1, so I'll just write 2 over here. I need the first 2 elements of this list, and if I print it, you can see that I get back Teddy and winters. And if I'm only interested in the last element, then I can directly index it as -1 and print it. I get S, which is my last element. And let's see if we want to, reverse the list, then we can just make use of colon colon negative and print it. So you can see my list also gets reversed over there. So these were the different things that one can do with lists and tuples. You can store different types of data under one variable, and you can make it a collection, and then you can iterate through. You can make use of list comprehensions and try to manipulate one list and create another list that you want to use for different purposes. You can do slicing, that is, you can extract the substrings or the subsection from the list that is of your interest and that is going to serve your purpose, right? So let's move ahead. So as I mentioned at the beginning that Python, there are so many libraries and modules and frameworks which are built on top of Python that, serve a particular purpose, making our development activities or automation activities really, really easy. And it has abundant color. So there is a function called as import, to import those libraries into your current Python program and then make use of different functions and classes and methods or variables, whatever it is, to So in this session, we are specially focused on one particular module or library called requests, which will help you to make HTTP requests to different URLs and fetch results and play around with it. Okay, I am going to consider the exact same example which our colleague Didier had considered while doing his API basics talk, but today we will be doing it programmatically using Python. So the method of installing these modules is very straightforward. If you have installed Python version 3.x, then you can just go ahead and type in your terminal pip3 install whatever the name of the library is. Right. So it will install that particular module. And then, as I mentioned, in order to leverage these or employ these in our programs, we need to make use of the statement import. So I will say import, and I'll also say import JSON, because while dealing with REST APIs, the communication is mostly based on JSON data, right? JSON payload. Okay. So the endpoint that we are going to hit first is the metaweather.com/API, and I'm going to navigation over there and then /search, and I'll give Paris as the query. So when I query this, I will get some, JSON response, and from that, I am going to get the ID. I'm going to extract the ID for which referred. So requests is the module we are going to use. Request.get will make a get call at this URL endpoint, and whatever the response that comes is going to be stored in this variable called response. So this response is of type response, and that has got different attributes. So it has got text, which will hold the response payload. It has got the attribute called status code, which will hold the HTTP status. So those are pretty much similar to that what comes in the REST APIs. So I will make the use of the if statement and see if my response attribute status code, which is referenced using a dot, response dot status code is 200. That is, everything is okay. Then I'll extract the text, that is the response payload, out of it and store it in a variable called Paris data. And then from that Paris data, I'm going to extract the attribute WOE ID, that is where on earth ID, and store it as Paris underscore WOE ID and print the. So we are going to check for the status code and print the Paris data. You can see the JSON payload that is printed over here with all different values, key values, that is title, that is Paris, location type, it is a city, and we also got a WOE ID with some IDs over there and latitude and longitude stored. So you can see that this has actually come in the form of a list, right? Because it is enclosed in square brackets over there, which is why while I wanted to extract this Paris where on earth ID, I made use of this Paris data, which is this whole thing that is printed of index 0, which will cover me this entire payload. And from that, I am extracting the key WOID, which will give me 61702. Okay, so the where on earth ID is extracted, and then we'll extract the weather status of that by making a get call to another URI, that is API/location. But this time I will be adding, this query parameter, that is Paris underscore WOEID, which we just extracted over here. Capture the response stream in this response stream variable. Again, check for the status code. If it is 200, then just extract the payload using dot text, that is the text attribute of the response body, and then print it out properly with some indentation. Okay, now let's execute this. It's going to be a pretty big payload over here. You can see that everything went well. The status code was 0, and this is the consolidated weather for the Paris, which we have fetched from requesting a get HTTP call or the get REST API call at this particular URL, right? I'm just skipping these JSON things. JSON is another module that is available, which will help us handle the JSON data type, that is the dictionary data type, where the data are stored in key value pairs. So when the response.stream.text comes, which is in the form of a string, so if I want to convert that into form of a dictionary where I can refer it with key values, I just make use of JSON.loads method and pass in that string, that is response stream.text. So response body will be a dictionary or a searchable map, wherein I can just say response body of sunrise. It will give, this sentence over here, that sunrise in Paris is at so that time over there, and sunset in is going to give me another time because I'm going to refer that sunset key. So how will we know this key and all? We just need to go through the documentation and understand what keys they will be passing as a part of our response body, and then make use of those particular keys in the right format in our Python code as well. So this is one way to import, one of the modules and then a different module and use them in combination to serve our purposes. And installation of modules is by using this pip3 install and then the module name. So I hope you got a clear idea, or at least a fair idea, on how to make use of the requests module to do different sort of get calls. Likewise, you can actually generate a payload. You can make dot post to do a post call also by passing the data, different headers, and the URIs into that function and get the response, and then perform different operations. So this is almost an end of this session. So congratulations, you have made it to the end. You said hello to the world. You have learned about different data types in Python, and you also learned how to create variables. We learned how to make logical branches in the flow by using if-else. We also learned how to loop through, uh, you know, uh, through a list and tuple, and also you placed a REST API call to fetch response and access different values. If this is not awesome, then what is? So what next? What after learning all these things? So this was just a very basic introduction where I have not even covered it. It's like 5% of what the whole Python is, and there is a lot more you can do with it. I have got two books from my side to recommend you all. There is a book called Automate the Boring Stuff with Python, Practical Programming for Total Beginners by Earl Swigert. And this book is so good that everything is explained like A for apple, B for ball. So this simple and this easy. And then another book which I want to recommend is How to Think Like a Computer Scientist. And this is mainly for those folks who come from a non-programming background. And these two books are beautiful, and these will encourage and motivate and inspire you guys to just keep on learning Python and explore it to the maximum extent.